Now let us look at how we can find out the area between two curves. Now of course we know how we can find out the area enclosed between a curve and any one of the axes. Let's say this is my curve, and if I find out the integration of this curve from this limit to this limit, I can find out the area. However, now I have been given two curves, one which bounds the upper curve from the down as well. So now how am I going to find out the area that has been enclosed by these two curves? It is very simple. Again, finding out the integration from a to b, keeping the limits same, and what we do is we subtract the upper function minus the lower function, and we find out this in terms of, let's say if we are integrating in terms of x, so we do it dx. So this is how we find out the area. Sorry, this would become our area. Now for example, in this question, let's say if I was to find out the area enclosed from 0 to let's say 1. So how am I going to write this down? It is going to be 0 to 1 root x minus x square dx. So this is how I'm going to find out the answer for this question. Now talking about area, let's say if the area is bounded by two curves and they are in a slanted way, like we do not know which curve here is upper and which curve here is lower. So what do we do for such situations? We again find out the integration from limits a to b. The limits remain same. What we do here is we subtract the right function from the left one, right minus left dx. So this is how we find out the area. Now here, what is my right function? Let's say if I was to find out the area enclosed from minus 3 to 1. So if I am finding out from minus 3 to 1, it is going to be this portion, this entire portion. So it is going to be minus 3 to 1. Here I would have, since this is in the terms of x, I have to convert this, take this out in terms of y. So this would become 2x plus 6 root under. And what would this function become? This would be y is equals to x minus 1. So how am I going to write this down? My right function is root under 2x plus 6 minus x minus 1 dx. So this is how I find out my area. Now talking about sign convention, as we all studied in definite integration, let's say if I have a function which is on top of the x-axis and I find out the area, it is simply going to be from a to b integration f of x dx. Now what if my function is below the x-axis and I have to again find out the area enclosed by it from a to b. From a to b, if I find out the if I find out the integration of a to b f of x dx, this value is going to come out to be negative because the function lies below the x-axis. So what do we have to do in such situations is that whenever, of course, now we have to calculate the area. So what do we do is we say this area, this area is equal to minus of integration a to b f of x dx, or simply in other words, how can we write this down? A to b f of x dx modulus, so that our entire area, which is going to come out to be negative because it is below, it would become positive. Now let us look at this diagram that has been given. Let's say this is my A1 area, this is my A2 area, this is my A3 area, and this is my A4 area. Now I have to find out the total area bounded by this curve and the x-axis. So of course it is going to be the sum of all the areas. So how am I going to find it out? It is going to be A2 plus A4, simply because they are going to be positive from the limits. They lie above the x-axis. The value is also going to come out to be positive. Plus what I would do is modulus of A1 plus modulus of A3. Because they are lying below the x-axis, that is why their values would come out to be negative if I take out the integration. That is why I already add a minus sign as I shown here, or I simply take the absolute value by putting the modulus. Now let's say if in a question during sign convention, let's say I have been provided with a graph which is in this way. Let's say this is my graph. Let's say this point of intersection here is somewhat C. Here this point is, this end point is B, and this point here, this is my A, let's say. This curve here, this is my f of x. This curve here, this is my h of x. Now I have to find out the area enclosed between these two curves from A to B. So what is the area enclosed between these two curves? It is of course this portion. Now you can see that for some portion f of x is greater than h of x, and from C to B h of x becomes greater. That means if I do upper function minus lower function, let's say if I say f of x minus h of x, so it is going to be positive from A to C, but it would turn out to be negative from C to B. And I cannot directly integrate it from A to B, because if I integrate it, let's say if this area is same as this area, then of course my answer would come out to be 0, because the negative portion would cancel out the positive one. So what do we do in such situations is that we integrate again from A to B. However, now we put a modulus sign, f of x minus h of x. Now if I was to remove this modulus sign, how am I going to do it? It would become from A to C, it would be f of x minus h of x, and it would become plus C to B. Of course, I hope you all remember this property that we studied in definite integral. I can always break down my upper limit and lower limit into several number of integrations by adding middle terms. So here C is my middle term, and from C to B it would become h of x minus f of x. Again, dx is here as well. So this is how I can do this. So you must understand the sign convention while you are calculating the area under the curve, because if you are not careful with the sign, the answer would turn out to be very wrong. So keep that thing in mind. Now talking about finding out area with the, let's say, y-axis. Let's say till now what we were doing is, if I have my f of x and I have to find out the area, I find it out on the x-axis. Now what if I have a curve and I find out the limit from A to B, which is on the y-axis? I have to find out this area. So how can I do this? What I do is, I can simply write down my area to be equal to, from A to B, the limits are what is on the y-axis, and this becomes f of y dy. I write my entire function in terms of, let's say my, I write down my y function which was in terms of x. I write down my function in x in terms of y. So let's say if, let me take one more example. Let's say if I have a straight line, which is, or let me take a different line. Let's say this one. This is y is equals to mx plus c. So earlier what we used to do, we simply used to integrate mx plus c. Now let's say if I have to find out the area and I know the limits on the y-axis, this is my a and b. If I have to find out this area, what am I going to do? From a to b, now I would write this function in terms of y. So this would become y minus c by m dy. So I write down the function in terms of x, which is going to be y minus c upon m, and then I integrate it. So you must keep this thing also in mind, because sometimes what happens is, it might be easier for you to calculate the area when taking it on the y-axis rather than calculating it on the x-axis. So keep this thing in mind. Apart from that, there was nothing else to tell you in this chapter. Now we'll of course solve a few questions so that you get an idea. As I mentioned earlier as well, this was a very short chapter. There aren't many things that we must study. The only basic concepts that you must understand about the sign convention, and let's say if there are two graphs present, how are we going to find out the area between them? That's all. Now let's look at the few